Okay, it's trying to focus right now. Okay, transformers. Transformers, by virtue of the name, they transform voltage levels and impedances from one level to another. And basically all they are is a coil of windings. And the ratio of the coils of counts of turns on those windings tells you whether it's a step up or a step down transformer. For example, say we want to have, we're going to make the numbers easy. Say you got 100 volts here and you want it to be 10 volts over here. Now that's going to be AC, which means alternating current. Now alternating current has a zero line and the voltage goes in a sinusoidal waveform up and below and up and below. So that's what's coming on your 60 hertz power line into your house, plus and minus 120 volts. So it goes positive, negative every 60 cycles. Oops, wrote that backwards, but okay. Or they would call that 60 hertz. So say you've got a device you need to run on lower voltage. So your 100 volt line coming in goes through a number of coils. Say, just for giggles, we'll say that has 1,000 turns of wire. And that usually goes around some sort of iron core. If you want that to be 10 volts, the math is the ratio of turns is also equals the ratio of the voltage. So if you've got 1,000 turns here and you want 10 volts here, you would put less turns or 100 turns over here. Now that's very simplified explanation. You know, the size of the wire, coils actually have what they call inductance, which causes frequency shifts and all that. But in the simplified form, that's all there is to a transformer. And it also provides isolation, because your 120 volts, let's just say 120 volts is coming in, and you wanted to go to 12 volts over here. Well, we'd have the same ratio, right? 120 to 12 is 10 to 1. So your 10 to 1 or 1,000 to 100 ratio would be the same. But one side of the AC line coming into your house is actually referenced to earth ground, which means that that's always 0 volts. So this is actually riding on 0 volts down here and going up to 300 volts or so. So you don't want that 0 volts. You don't want that tied into your circuit and everything. So this actually, you know how a magnet will repel and attract depending on the polarity of the magnets? Well, that's what's happening here. When the current goes positive this way, the field around it, the magnetic field around it expands positive. And when it goes negative, it actually collapses and changes its own polarity. Well, what that does is when these magnetic fields passing through these coils, it induces, that's why they call it induction, it induces a current flow plus and minus back and forth through the other secondaries. And that's all there is to it. Now, if you want a high voltage coil like the one in your car that goes from 12 volts to 20,000 volts, your primary coil would be the low windings, and your secondary power would be the coil windings, which are thousands of turns. And what happens with that is when the 12 volts comes on via the points or the electronic switching in your car ignition, charges up a field around that thousand turn high voltage coil. When your points open, the coil collapses, the field collapses, and it basically, if you can think about it like squeezing a plastic bag full of air, it pushes the electricity out the high voltage based on the ratio of those turns out to your spark plug, which causes it to spark because there's a gap there and the voltage is so high, so it's kind of like a static discharge. It doesn't have a lot of current, so it can't hurt you, but it's very painful. All right, I hope that wasn't too complex, but very simple. Just remember, the turns ratio equals whether you want to step up or down, and it's pretty much a 1-to-1 ratio in that. So 10 to 1, 100 to 1, whatever you need to do for the step up or step down. All right, let's go on to this video. Got me a little special project today here at the Retro Electronics Workshop. This is from an old Line 6 kidney shaped effects amp modeler, if you will. They were very popular back in the 90s for making your regular amp sound like something different, you know, a different brand, a different setup. So unfortunately, what is wrong is right where the wires exit the strain relief. You can see this wire has become fatigued, and the bare copper is right together there. Now these are 6 volts at 2 amps. So what I'm doing is I've taken my utility knife and I've gone around the perimeter. At the bottom you could see a seam here. So I started scratching this seam with my utility knife, kind of getting across the ends here if I could, and all the way around. And then I took a heavy screwdriver handle and started wrapping, and you could hear it popping. Okay? And then all of a sudden she popped apart a little bit. So that's at the point that I'm at right now. So let's see what we got inside. All I need to do is cut these wires and draw them inside. Come on, baby. Yeah, it's breaking a little bit. But you know what? I don't care if it breaks. I wanna, here, let me beat on this a little bit. Okay, there she goes, she broke. That's fine. I'm just gonna super glue it back together. Now there's the 2 outputs. Now this is supposed to be regulated, but it doesn't look like it is. What does it say the output is? 9 volts AC, so that's all this is a 9-volt transformer. You know what? This would work awesome as a replacement in the Commodore for the 9 volts. So, as you can see, if this is molded, see that's molded onto the cable, so I'm just going to have to cut this off. And I see the white one goes on the left. Let me cut this back. This is a pretty simple fix. I thought this was a nice regulator. This is just an AC transformer. Must be all the regulation is inside. Again, the white one goes on this terminal. It doesn't matter, it's AC. Means alternating current, which means it goes, each side goes positive and negative alternately, so it really doesn't matter. When how a transformer works is it just has that iron core that you can see, that big gray block, and it's laminated many layers. I'm heating the solder up and shaking it off to get these holes open. There we go. Very complex, isn't it? I thought there was going to be a nice regulator in here. So all I'm going to do is cut this wire back and restrip it. And I've got several layers of, I got a new stripper here I want to try too. I've got lots of heat shrink here. Let me see if I can find it. There we go. Lots of heat shrink. And maybe I can put several layers on the where it comes into the transformer, but what I can do is put like a knot in it so it flexes around a little bit. So this is a pretty easy fix. I got these new strippers a friend brought for me. I know you're not even seeing my face. These kind of, they look like a cartoon character, don't they? Some kind of dinosaur. Alright, so I'm just going to strip this. Wow, they do work good. Look at how that works. You just put it in there and it pulls and it bites. And let me see. How do we want to do this? I want to put a couple pieces of shrink on here first. Oh, excuse me. And then I'm going to put a long one. I'm not sure exactly how I'm going to engineer that one. I'm going to put a little tin on these wires, which means I'm just going to solder, let a little solder soak into these wires and stiffen them so they won't unravel while I'm working with them. Alright, so now we're going to put our heat shrink pieces this guy. Has he got an obstruction on it? It does. Okay, I gotta cut a new piece. Ain't rocket science. Alright. Well, this was pretty simple. Much simpler than I thought it would be. Are you sitting in camera view? Yes. I'm trying to make more precise views of what my hands are doing. Where's my little pliers? They're there, porcupine. The beauty of this line 6 thing is I don't need an amplifier. I can use this line 6 modeler, as you would call it, maybe. Okay, squeeze that down. Now after you solder a joint, you want to hold it still. You don't want it jumping around on you. So get that nice and hot and flow. This one didn't get tinned as much, but it will when I solder it. Alright. In goes the big hairy arm. Alright, so shove those up on there. And I have a heat gun, but I don't know where my heat gun is, so I am just going to use the soldering iron to heat this. Now the barrel of this soldering iron is very hot, so I'm just going to rub it back and forth on this heat shrink. And heat shrink doesn't really shrink, it returns to the shape it was. When they make it, they stretch it while it cools, so that when you heat it, it relaxes back to where it was and then cools again. So it doesn't really shrink, it returns. So what I can do is figure out how I'm going to strain relieve this. Now this thing, I'll just put some electric tape around this actually. I gotta see how big the hole is where this exits. It looks like the line cord is fine. So we'll drop this guy in here. That strain relief will go in that hole. What I'm going to do with this is press these down Stick that down inside like so. This doesn't need to be super long. The wire is pretty brittle, actually. I probably should be changing it, but I'm not right now because I just want to use this pedal. Oops. I want to use this pedal right away. So, be it good or be it bad, I'm tying a knot in it. And twisting it around down in there. Shove it down on the bottom. Now I'll just have to remember to be very careful with this. And let's see if we can make the lid fit back on here. I think we can. Yeah. It's not so bad, is it? I'm just going to put electrical tape around it, guys. This doesn't get hot. We'll put the point of view out here a little bit. I'm going to put a wrap at each end, and I'll be able to use my power supply. And I'm just going to put 3 or 4 wraps around each end like this. Stretch it just a little bit. I'm going to put it across the bottom. I'm going to cut it. I'm not going to rip it. If you rip it, you overstretch it. And that's the name of that tune, I think. I don't care if I can read it, I know what it is. I can see that it says 6 volt or 6 volt AC, 9 volt AC. Okay. I'm stretching this a little bit as I pull it up and around, and that'll keep this thing together. I mean, I've got electrical tape that's been outside at my lake property in the weather, wrapped around a post, holding wires and stuff. It's still stuck perfectly. Okay, so there's our little job. Now I'm going to plug it in and put a meter on it, and we'll see what the voltage is. Alright, I got my fluke out. I've got the power supply here. Here's the end. And you'll see that it's reading a lot of little random numbers there because there's noise in the air, AC noise from the AC lights in here. And the meter is very sensitive, but if I probe the center of this and touch the barrel, I get 10.9 volts. So that's typical. If you look, remember your Commodore 64s, their AC 9 volts without a load is 10 something, 10.6 or so. So this would make a good transformer for the replacement brick in the Commodore 64. I've got 2 of these power supplies. I was going to look at the other one, but maybe I was going to fix that one. But we'll fix the other one the same way, and then we'll see where we go from there. So there's that beast. And wish I could save this, but I can't. And so we know that this is AC, so we don't care. I don't care no more. Actually, scissors sometimes work just as good as well. Alright, is my iron hot? No, I unplugged it. So I'm going to have to wait a while my iron warms up, because I had it unplugged to plug the other power supply in to test it. And you'll notice a lot of items, like this power supply, the power plug is not polarized because it's AC. It's not ground referenced. You can go in here either way because this transformer doesn't care what polarity the AC line coming in is. Positive that's perfect. That looks pretty good. Now let's test this one. Now, because you're going to be upside down when I display this, I will turn my meter upside down. And hopefully it's not glaring. Here's the Line 6 power supply. There's the cord end. Where's the power supply end? Right there. We will have to unplug the iron again. Okay. This should read about 10.5 volts if it's like the other one. Ooh, that one reads 12.5. That's a hot power supply. But AC, it all depends on how your meter averages too. This is a good fluke, so that should be the pretty good RMS average. It says true RMS because true RMS means it takes into account abnormalities in the sinusoidal waveform, which is, you know, the sine wave, the wave shape. All right. So that one's fixed. Now I can play with my box. So guys, that's a very simple repair of a couple of these things. I said this is retro. This is 90s. I guess that's pretty retro. This is 90s products. It's just a dang transformer. That's all it is. Alright guys. We'll see you later on another episode of Bob's Retro Electronic Workshop. Be sure to check out all my videos on Bob's Barn Workshop. And I thank you very much for watching. Take care. Take care. God bless.